going to talk about section 10.5 and 10.6. What you see on the screen right now is a summary of theorems 86 through 88, and it looks like an awful lot of information. You see that you have a central angle, and as we discussed yesterday, the measure of the central angle is equal to the measure of the arc. I have a chord angle, angles formed by two chords, inscribed angle, where the vertex of the angles on the circle and the sides of the angles are two chords. I have a tangent chord angle, secant angle, tangent angle. We discussed this yesterday a little bit about the ice cream cone theorem where I have congruent sides. Today we're going to talk about it in the context of angles. And I have a secant tangent angle. And again, it looks like an awful lot to remember. But you can sort all this out by looking and seeing that when the vertex of the angle is on the center, oops, wrong color there, I've got a white pen and rather than a colored pen. When the vertex of the angle is on the center, the angle, the measure of the arc is equal to the measure of the central angle. When the vertex of the angle is in the circle but not on the center, the measure of the angle is equal to half the sum of the arcs. And they are the arcs on either side of the angle. Notice these two angles here are vertical angles and they are congruent. The inscribed angle has the vertex on the circle itself, and so does this tangent chord angle. The vertex is on the circle, and the formulas are the same for both of them. The measure of my angle is equal to half the intercepted arc. In these cases, the vertex of the angle, this is where the vertex is on the circle. In these three cases, the vertex is outside the circle. And you'll notice that the formula is consistent throughout. It is the measure of my angle is equal to half the difference of the big arc minus the small arc. And I really think about it that way. If you look here, here's my big arc, here's the small arc. It is half the difference between the big minus the small. The words I think of up here is 1/2 the sum of the arcs. And over here, just like the book says, the vertex, if the vertex is on the circle, the measure of the angle is equal to half the arc. There are two more theorems that go along with angles and circles. If I have two different inscribed angles intercepting the same arc, and that would be this one right here, the angles are congruent. And that only makes sense because each of these angles would be half the measure of the intercepted arc. So let's go through the first two theorems. If two inscribed or tangent chord angles intercept the same arc, then they're congruent. So that's pictured below. The second one says if two inscribed or tangent chord angles intercept congruent arcs, then they are congruent. So it doesn't necessarily need to be the exact same arc, but if the arcs are congruent, the angles are going to be congruent as well. Now, here's three examples to illustrate what I've been talking about. Notice the first one, the vertex of the angle is inside the circle, but not on the center. So the measure of my angle is going to be equal to 1/2 arc 1 plus arc 2. And then I'm just going to substitute in. And when I simplify, I find I get 57.5. Now, in our next example, let's group this together and make it a little bit smaller. In our next example, The vertex of the angle is outside of the circle. So my formula is going to be the measure of my angle is 1/2 the big arc minus the small arc. So let's plug in y equals 1/2 57 minus 31. And then you get 13. And these are degrees. I'd like for you to try the third one. Notice the vertex of the angle is outside the circle. Pause your video and then press play so that you can see the answer. You should have gotten 53. If you did not, go back and check your work. Now, this one's a little bit more challenging because I have to think about multiple things in one problem. I have several different angles here. I have one angle where the vertex is outside of the circle. I have another angle where the vertex is inside the circle but not on the center. And I have several arcs involved. I have some inscribed angles, Z and N. And let me erase. I don't want you to think those are congruent. So I'm just going to figure out what kind of relationships I can set up so that I can solve for all of these different variables. Let's first look at this 24-degree angle. In that one, the measure of the angle is going to be 1/2 the big arc minus the small arc. Well, I substituted in already, I guess. So I'll have 24 equals 1/2 x minus y. Now, I'm going to turn my attention to my 65-degree angle. The measure of that angle is going to be 1/2 arc 1 plus arc 2. And then I will substitute in there. 65 is equal to 1/2 x plus y. Now I have a nice system of equations to solve, or maybe not so nice, but in any case, it is solvable because I have two unknowns and I have two equations. So pause your video and then come back and check your answer. Here we go. I found that x is equal to 89. My work is shown. And y is equal to 41. So I plugged that in over here. And then I found that z and n must be 44.5 because they're half the measure of the intercepted arc. Now, take a look at this picture and try to make a generalization. See that I have the diameter of the circle drawn, and again, the vertex of my angle is on the circle. Pause your video, think about it for a second, and then press play. It just so happens that this corresponds with a theorem of ours, where if I have an angle inscribed in a semicircle, it is a right angle. But of course, based on the theorems we already know, we can figure that out because a semicircle is 180 degrees, and my angle is on the circle, and it intercepts this arc, so the angle has to be equal to half the arc, or 90 degrees. Here's another theorem. The sum of the measures of a tangent angle in its minor arc is 180 degrees. Well, this is kind of nice because it saves us from going through the trouble of saying measure of my angle is equal to 1/2 the big arc minus the small arc. In this case, this angle and this arc sum to 180, and it allows us to solve some problems rather quickly. And of course, you've copied these down already. Now, here's one other problem. We're going to use what we've learned to figure this one out. Now, I am given the arc AB is 145, so I'm going to write that in. And measure of angle Y is equal to 48. So, I'd like to find the measure of arc AC and angle D. Now notice that I have a angle here where my vertex is outside of the circle. And remember the theorem we just discussed. The measure of this arc plus the measure of the angle is equal to 180 degrees. So this must be 132. Measure of all the arcs in my circle is 360. So if I take 360, subtract 145 and 132, I get 83. And there's the arc that I'm interested in. And now I'd like to find angle Z. Well, angle Z, of course, and arc AC sum to 180 degrees. So angle Z must be 180 minus 83, which is 97. Now, that is all the theorems that I'd like to discuss from section 10.5 and 10.6. I'd like you to try the homework for tonight, and then we will discuss it tomorrow. The homework will be posted on my website. Thanks, and have a nice night. I hope you had a really successful AP exam.